Okay, hello and welcome to today's Developer Skill Sprint. Today we're going to be doing an overview of Enterprise Mobility Services. I'm JT, Director of Application Developer Products, and I'm also here with David I in the studio.
Hello.
Hi David, thanks for joining us. So I think everybody here is well acquainted with the basic agenda of Skill Sprint, so we'll just jump right into it. Today though, I'm going to give you an overview of Enterprise Mobility Services, a little background on what motivated the feature or the product, and then we'll do a demo as well. And just to also to let you know, this is a two-part series. Today I am covering the overview and a simple demo of a REST API. And on Tuesday, Marker will be here in Scotts Valley, and he will be getting into the data access element of EMS. So let's start with the challenges that we have been hearing from enterprises when mobilizing. And when we say mobilizing, we mean making their enterprise available generally to their end users. And when I say end users, I mean employees primarily, but it could also be consumers as well. And you know, the unique concerns of the enterprise. And when I say an enterprise, I mean, you know, a company with intellectual property that sits behind a firewall that they need to expose onto mobile systems. So the main challenges we heard that drove the design and features around Enterprise Mobility Services, or EMS, is first of all, enterprises need to be able to get to that intellectual property, that data that's living on the back end somewhere, typically in a SQL database. They need to be able to do this securely and robustly. They need to be able to move it over to a mobile device and present it. You need to be able to make changes and or keep that information secure on that device, and also make sure those changes are reflected back in the central data store. The other thing that's been happening in enterprises, and this has been going on for a few years, is custom APIs and extending the infrastructure to developers within an enterprise by exposing APIs to developers. So this actually has been going on for a long time, but over the last few years, there's really been kind of a revolution around REST as a technology on which to base these custom APIs. They're very easy to work with from any language, very straightforward technology, very robust in the sense that it's completely stateless and asynchronous. So it can handle situations where, for example, you may be accessing data and lose your cell signal. And you'll be able to recover from and or work within that situation due to the fact that you're not managing session state that can get corrupted during that scenario. So this is one of the bigger challenges that enterprises are dealing with. How do we expose our infrastructure to our developers, to third-party developers, in a way that makes it useful and robust and scalable? A forever challenge has been we got to talk to databases. We got to talk to the big guys, Oracle and Sybase and Informix and SQL Server and others. And we need high performance access to these databases. So that challenge has been one that's been around for a long time as well, and we continue to put a lot of focus in that area. And the final challenge has been kind of a newer challenge with regard to exposing services from an enterprise, and that is the analytics around that. Understanding how end users are interfacing with or accessing this information through either these REST calls or through data requests, and understanding and managing the users that can get access to these resources. So it's a combination of user management as well as analytics to understand how users are interacting with those services. So these were the main challenges we've heard from enterprises that have driven the features that comprise Enterprise Mobility Services. So now we'll get into what is Enterprise Mobility Services. So it is a turnkey middleware server. And basically what we mean by turnkey is that it is a piece of software that comes pre-built with a lot of functionality that you can just use out of the box and that you can easily deploy. So you don't have to build a bunch of services yourself and go through machinations to deploy it. All this is easily packaged so that you can build against it and deliver against it very easily. So it's middleware because middleware is really the most robust way to interface with mobile systems rather than doing direct connections to database from a mobile device. You know, think back to that scenario where you can lose a connection. Using middleware, a stateless service, is really the most robust way to make that happen. So within this middleware server, a couple of key features that we've delivered that make it turnkey. One is user management and authentication. So there is a database that is part of EMS that allows you to keep track of the users that are allowed to interface with those services through EMS, to manage groups of users, to assign rights to particular resources or to particular services. The next thing is being able to easily extend the infrastructure via APIs. And so delivering custom APIs over REST is the direction we went with EMS. And we also took the approach of doing loadable modules. So in the production version, which is an ISAPI module, you're able to easily add loadable modules into your ISAPI server that can add new APIs or replace APIs and allow that to be done on a live production server. So you can just restart that module and you're up and running in a split second. Of course, Enterprise SQL Database is critical, and so part of this delivery has been database access through the standard REST protocol. And when we say database access through REST, we mean sessionless, we mean stateless, unlike DataSnap, and we'll do a little comparison here toward the end, but it's a fully stateless solution. And so it can deliver the same kind of benefit that DataSnap did in terms of marshaling data through the various tiers, but it does so with a standard REST interface, standard JSON. So for example, I could use a completely different language on the client side to talk to it because it uses standard REST. As long as that language can support HTTP requests and understands how to work with JSON or can parse text files, you can work with it. So that's pretty much every language out there, by the way. The other thing that was really important for enterprise was security of information and data store. So although most enterprises have very big vendor databases, we've offered in EMS Interbase Server, a full server-side SQL data storage solution to EMS subscribers. This means that you have an additional database that you can use with EMS on the server side. Additionally, we're also offering up Interbase to Go licenses. So these are embedded databases that will be deployed with your app. And the big benefit of Interbase to Go, besides performance compared to SQLite, for example, is the fact that it can be encrypted. And that is really important to enterprises. When you get that data onto the mobile platform, it's sitting on somebody's phone, and they lose that phone, you want to make sure that that data is safe. This is called the data at rest issue that most enterprises are challenged in managing. So encrypted data store through Interbase to Go on the mobile side. And then finally, powering all of EMS is a database, an Interbase database behind the scenes that is keeping track of all the activity of the server and the services. And from that, we're able to deliver a console that is accessible via the web for doing user, device, and API analytics. And of course, all of these are APIs that are also available to writing rich clients or any kind of client that you want to do further analytics of this information. So you can get access to the user table, you can get access to all the analytics through standard REST APIs as well. From an architectural perspective, let's talk about the components of EMS. So we'll start with really the core, which is right here in the middle. This is the middleware. It is for development purposes, it's a standalone server that you would build an EMS package for. For production purposes, it's an ISAPI module that you would install into an IIS server. And you would be able to install these packages when you need to into that server, so they're loadable modules. This lives with your web server, again, as an installable module, and there's an EMS database that is tracking the interactions with those resources. It's also managing the user accounts and the authentication of those accounts. So these two are two pieces that are part of the turnkey solution that get deployed when you go to production. You deploy the ISAPI module with the set of packages and the database along with it. With that database, you are able to access a console, which runs on a separate port, and start looking at user tracking and REST API analytics via the web console. Of course, as I mentioned, you could also just make REST calls into the server also, or for that matter, you could talk directly to the database. For data access on the back end, we have our high-performance FireDAC data access components, and with great support, high-performance support for all the major databases, and an included interbase server license for you as well. Now, this component here is delivered by the BAS components that we delivered in XE6, and it's meant to, point out that there's other services you're going to use. Cloud services are part and parcel for delivering any kind of distributed solution today. There may be things that you want to get from, let's say, a mobile backend as a service like Kinvey, or that you may want to interact with a social network. So working with these components in the middleware is a way for you to aggregate that information in your middleware layer as opposed to managing it just on the client itself. On the client side, the REST components that we delivered back in XE5 are how you would primarily interact with the service. And so we'll do a demo here in a moment of how that would look. But the other thing I wanted to point out is that you do also get the Interbase to Go licenses as part of your EMS subscription, and it is that embedded, secure, encrypted database that you can use on the clients. So that's kind of a component look and a really high-level architectural look at how EMS works and interacts with, at least a three-tier system in this regard. Here's a quick example of what the analytics look like. So I would just open up a web browser, point to the port, log in, and then I'll be able to see which users are registered, are they active or not, what groups they belong to, what rights they have, which devices are interacting with the service, so you can know which devices a user is using, for example, and also analytics on the API calls in particular. So you'll be able to know how many people are calling my check date and time service, and engage which APIs are worth investing in more because users are interacting with those more. So this is a big part of understanding the usage of your end users through this service. So now let's just do a quick demo. In this demo, I'm going to build an EMS test server, show you how to get one up and running. We'll be using the development executable that will run on Windows. I will create a REST API, a really simple API that shows you how to add a resource and kind of how the format looks. And then we'll do a demonstration of calling it from a client. And just as a reminder, on Tuesday, Marco is going to go the next step, which is working with data using EMS. Okay, so what we're going to do is we're going to do a new other EMS package. So the package is how you basically build a unit. Now, from here, this is going to build the standalone server version. It can create an empty package, or I can create one with a resource. So I'm going to choose a resource because I want to create a get a resource that I'm going to add a REST API on top of. So I'm going to name that resource. I'm going to do a simple reverse string example. So a string will be passed to me, to my service, and the service will reverse it and send back that reversed string. And I'm going to do get requests only for this endpoint. And of course, you have support for pretty much all the standard endpoint type of requests. So let's look at the code that was generated for the get and get item. So the reason why I'm going to use get item is because it already fills up the parameters that I'm going to be receiving into a handy L item that I can work with. So that L item, what I'm expecting somebody to send me is a single string that I will then reverse. So the way that I send it back is I use this response object right here, and I create a JSON data packet. that can be sent back to it. And it's a lot simpler than it sounds. So let's just show you a line of code that does this. I'm going to use that response object. And in the body of that object, I'm going to set a value. And this value needs to be a tJSON value and a Boolean. So we're going to create a tJSON string. And let's just finish the second parameter here. This gives ownership in terms of automatic reference counting. And in here, I want to take the string that was passed in, which is going to be stored in this L item, and I want to reverse it. So I'm just going to call an API function called reverse string and give it the L item. And it looks like I forgot to add my uses clause for that reverse string function. Okay, so that's really all that's required to get an API up and running, a GET API up and running that takes parameters. So let's go ahead and run this server, and I'm going to run it on 132 here, and it is on port 8080. This calls a created endpoint called version that you can call anytime to know which version is being run. But let's go ahead and call the API that I just created. So the way that REST works is each of these endpoints represent a URL off of some base directory. And the name of that endpoint is the function name. So in this case, if I just call reverse string and don't pass it anything, I get nothing back. And now I pass the parameter as the next element in this URI. So since David I is here, we're going to reverse his name. And you see that what happened was the call went back to my REST resource and sent me back a JSON data packet that was a reverse string. You can also see that the calls are being logged here in this log. This is information that will be stored in the database that we'll later use for analytics, and Marco will go into the details on the analytics on Tuesday as well. So how do we create a client now that can talk to this? So let's go ahead and create a new application. Okay, so here we have a basic Windows client, and since we're going to make a REST request, I'm going to grab a REST client, and the first thing we're going to do is we're going to set it up to point to my server, which is the base URL property, and this one is running on localhost port 8080. Now we need to make a request. So let's grab the REST request, and while we're at it, let's grab the response too. Because these two are intimately connected. So in my request, this is where I'm going to plug in that resource. So that resource name was reverse string. And for sake of demonstration, I'm going to go ahead and just add the argument right here in this resource so that we can execute the call right here in the designer. So it made a request and it was successful. Now we can look at the response, which gets that JSON data packet and see that I got back that information that I was expecting, my reverse string. So now let's make this dynamic. We'll take a string in an edit control, and in an on button event, we will send that string over to the REST service and ask it to be reversed. So we'll take the REST request, and we will tell it we want to go to this resource, and we'll give it the name of the resource again, which is reverse string. Don't forget the / plus whatever's in my edit 1 control. Okay, and now we're going to execute that request. Now you see there's async executions as well. This is what you would normally use, but for the sake of demonstration, I'm going to use a synchronous execute so that I'll get a value back that we can show, because we want that information in the REST response or a show message. There we go. That should do it. So let's make sure this works now and runs. Okay. We'll put David I's name in there again. And voila. So if we go back and look at the console, we'll see that that was also called there again. Reverse string was called right at this time. So that was a quick demonstration of how easy it is to take a turnkey solution like EMS, build a server up, add a REST call, and interact with it from a client. Tuesday, we're going to go one step further. We're going to work with data. We're going to do a very interesting master detail demo for you, and Marco will be here in Scotts Valley to demonstrate that for you on Tuesday. Before I'm done, I'd like to take a quick moment to just share with you some of the key differences between DataSnap and EMS. DataSnap and EMS are both middleware solutions. They both support remoting to some extent, and but they have differences both in how they do it and also in how they where they're delivered in the product, and lastly how they're licensed. So as we talked about, EMS is a pre-built turnkey set of services. These services are provided out of the box, ready to go. DataSnap can add these types of services, but these are things you have to write. So it's more like an SDK for building these types of services. So if you wanted to do user management, for example, you'd have to connect to a database, set up your tables, and manage those things. If you wanted to do analytics, same kind of thing. You'd have to capture that information, and you'd have to build out your analytics engine. These are things that are provided in EMS. These are things you could build in DataSnap. The other big difference is DataSnap does have a REST JSON implementation, but it's custom. It uses sessions, for example, and this is historical. This is through years of building solutions around DataSnap and making it interact with updated technologies like REST. There is value to doing things in sessions, but there's also it also does have an impact on the robustness. If, for example, losing that connection can wreak havoc on a session, whereas if it's stateless, you don't have that concern to deal with. So that's kind of the big difference between DataSnap and EMS. EMS uses a fully standard REST JSON implementation, which is a stateless asynchronous implementation. And because of that also, it's much easier to use other language front ends, other solutions that you may already have out there in the field to interact with the EMS services. DataSnap is included in Enterprise and above, and with that you can deploy DataSnap for any number of users without additional cost. EMS, on the other hand, is a per-user licensed solution. So depending on the number of users that are registered in the database to access those services, that's how it's licensed. And there's sets of numbers of licenses you can buy to enable up to that certain number of users, and you can buy additional licenses if you need to grow that. EMS is also available to pro users with the client server add-on pack. So if you're a pro user and you want to access EMS, you just need to get the client server add-on pack, and you get access to all the great services and features that we just shared with you. So in closing, I just want to go over the components of EMS one more time. It's a turnkey service that you can deploy via iSAPI with plugin packages. It includes a database for user management, analytics, and all that other stuff. It includes built-in analytics that you can access today to understand the usage. It includes an inter-base server as well as the FireDAC drivers for all the major databases, and it also includes an inter-base to-go license for each of the devices that are part of your delivery of EMS. So, ready to take some questions, David?
First one, Alf was asking about, is it easier to debug database connection errors with EMS than DataSnap and find whether it's the database or something else? And I replied, your modules are the code in your modules are the things that are going to do database access.
Correct.
As JT showed in the block diagram, your code in the modules is doing that work, whatever it needs to be, whether it's calling a SOAP server, a REST server, a DataSnap server, a SQL server, an Oracle database, whatever is outside of the EMS server box, is in going to enterprise systems
Mm-hmm.
is in your modules, in the
Right.
code you write, using FireDAC and so on. So all the same rules apply whether you're building a desktop application in that respect or you're building an EMS module.
Right.
As it relates to database connectivity.
Yeah, and I'd say in terms of debugging, they're pretty similar in terms of ease of use. Certainly, debugging on a standalone client is going to be a lot easier, standalone server, than an ISAPI module. But yeah, they're pretty equivalent in general.
And there you're talking more about the debugging the modules and the EMS system. With DataSnap, you have the extra flexibility and also extra complication of having different life cycles for all of and multiple different server classes. In this case, it's stateless, and you have modules inside of an EMS server
Correct.
that you plug in.
Yep.
So they're isolated, and as JT mentioned, they're stateless. Here, scroll back up. Stefan was asking, he said, is there support for transactions over rest related to database tables? And again, the database, your modules are doing database work. So whatever they need to do for transaction processing and so on, you need to cover in your modules themselves. Correct. As far as transactions over REST calls, it's stateless. There's requests come in and they go away and they're gone.
Exactly. So it's not like what maybe when you're talking about transaction from many years ago where there's session around it, that's not the case with EMS. We manage that in a different way. And Marco will go into that on Tuesday when he talks about how we manage data back and forth. So definitely come to the Tuesday session as well.
Yeah. Let's see. Okay. What is the cost of the per user license? Scott asks.
Well, there is information about that on the website, but basically you buy packages of licenses up to a certain number of users. So you can buy, you get, 5 are available with the product to test the application. And your first entry point would be for up to 100 users. And in that case, the per user cost is $50 or $49.95 is the package cost to support up to 100 users. You can buy additional users at that rate. If you're going to support more users, you can buy the 1,000 user package, and the price goes down on a per unit or per user basis as you buy up or buy more user packages. So, for example, the $1,000 package, the per user price, pardon me, is $34,995 or $35 per user, and so on and so forth as you buy these packages. So packages of 500, 1,000, 5,000, and more. And if it's more, then you can certainly work with our sales team to negotiate that cost.
And that's per year as well, is that right?
That's well, it's a perpetual license.
Okay.
The annual cost gives you the maintenance and new features that are put into EMS to deploy those new versions.
Okay. And then, again, the 5 user license is for development and testing, yes, not for deployment.
Correct.
Okay.
If you only have a 5 user deployment, it's probably a little more than you need.
Okay. Let's see. Oh, a couple of questions about what I answered Scott as far as EMS is new in EXE 7.
Correct.
And App Method September 2014.
Correct.
What editions does EMS come with?
It comes in App Method. It comes with all editions.
Okay.
In RAD Studio, it comes in Pro Client Server or above.
Okay, so if someone has the Pro and they buy the client server add-on pack,
yep,
or they have Enterprise,
correct,
and above, then EMS is included.
Exactly.
For development, again, you still have to come back and when you want to deploy and buy licenses, get access to ISAPI module.
ISAPI module, exactly.
And in the test case, you were using the test server and the test console.
Correct.
Right. So as part of deployment, when you get user licenses and you're deploying the servers, you'll get a console,
correct,
and a server container,
and the database, yes.
Right. And the other thing is you can put these anywhere, right? Somebody was asking, can I put them in an Amazon Windows instance? Can I keep them inside my firewall? You can deploy EMS server and modules wherever you want.
It's true. Although, again, we were trying to solve a very specific problem here around enterprise mobility. So, although you can make it public or put it on a public server, generally this is meant to be an on-premise type of solution.
Does EMS support non-Delphi clients? For example,
yes.
If you have a PHP client.
Absolutely. And that was one of the motivations behind making a standard REST implementation so that other clients can easily interact with it. Absolutely.
As long as they can do HTTP and JSON.
Correct. Exactly.
Which
pretty much every language.
Which is what REST is,
yep.
Right? Yep. And I can't think of a language
it doesn't.
I mean, JavaScript, everything, right?
Yep.
For REST, and that's again why. Okay. Let's see. Gianni is asking about what is the EMS framework using for its underlying communication? Is it using Indy for HTTP?
It is right now. Although on the roadmap we are working on another HTTP implementation. But yeah, that underneath the covers there is an Indy HTTP component.
Okay. Type while you're talking instead of trying to talk. There are also, let's see. What happens if you exceed your user limit?
Then you will not be able to add users to the database to access those services. So you'll either need more licenses or you'll need to replace some users, make them inactive, and add new ones in.
So again, Thomas, EMS and Rad Studio Pro, get the client server add-on pack. If you have Rad Studio, if you have professional version
yep.
of any of the products.
Client server pack will deliver it and enable it.
Okay. Yeah, again, there's people asking about price per users is meant to be implemented by a small fish, meaning a small company.
Well, certainly.
With high, maybe 20 to 25 to 30 users. There's 5 packs, right? Or a 50 pack?
There's a 100 pack is the smallest pack today.
Okay.
Although I'm sure we can work something out with the sales if it's a smaller implementation. But 100 pack, I believe, is the smallest pack we have available today.
Okay, and I'm just saying to Colin, just contact sales. I'm sure they'd love to. And then question about, are we talking about concurrent users or the users somehow identified? JT, you said.
We're talking about a named user,
basically. Yeah, it's users that are active in the
EMS database.
In the EMS database.
Right. And that information can come from Active Directory or LDAP, so someone here asked about internal users. That's generally how that would be managed. So yeah, the number of concurrent users doesn't matter. They can access it from any number of devices as well, but they, especially in the enterprise, will need to log in and authenticate, and then they will have access to resources based on that authentication.
And again, the database that's interbase for EMS, there's an included interbase database for user management.
Yes.
Right. So when you add users, delete users, activate.
That's part of your deployment of EMS, correct?
There's an interbase version that's buried inside of there as part of your deployment. There's also that same interbase database is used to store analytics.
Correct.
Okay. But then if you want to get to data, that's whatever database you want.
Correct.
FireDAC, whatever mechanism you want from your modules.
Typical Fire or data access using FireDAC with an additional license for interbase server for the same number of users. And as we mentioned, also for interbase to go databases too.
Richard asks, if I write one mobile app to the interface with an EMS server, is that considered one license for many mobile users?
It depends. It doesn't depend on the device. It depends on the user. So if all these users use one mobile device, you're going to count the users. If one user uses multiple mobile devices, you're still going to count one user. So basically the way it works is that when the user goes to access the service, he needs to authenticate. We need to know that he's able to access that resource. So that information is kept in the database, and that's how we keep track of users. So again, it doesn't matter on the number of devices. What matters is how many users are gaining access to the EMS service as managed by the EMS database. Hope that answers the question.
Okay. Is DataSnap going to be phased out in the future?
It isn't. We're going to continue to support DataSnap. We're going to continue to add features to it and platform support as we go forward. DataSnap is a value to enterprise and above users, so we especially there's been a lot of people who've built implementations around it, so it's going to absolutely be supported and updated and continue to be available for enterprise and above licensees. EMS is an alternative approach where we can get you up and running quicker with these set of services, but does have that different licensing option.
A couple people are asking, where do they learn about EMS pricing?
So we do have a web page that talks about enterprise mobility services, as well as some pricing information on the shop site. Basically, the way it works is there's tiers of user packs that you buy. If you've purchased any kind of backend as a service or database licenses, it's a very similar concept. You say, I'm going to have this many number of users. You get a license pack that enables that number of users. If you need additional users, we can add those additively. So I believe the smallest number is 100 users, which costs $49.95, and that equates to about $50 per user. So if you need additional licenses, you can buy them at that price point. If you go up to the next tier, which is 1,000 users, then it comes down to like $35 per user, so on and so forth as your volume grows. So that is that's the basic idea, and the pricing information goes up to a couple of tiers, but for more detailed pricing, we do want you to interact with the salesperson because you may have unique needs also that we want to make sure we understand. That's also how you get access to the ISAPI module as well at this point.
Okay, let's see. Assuming DataSnap stays, noting your comments regarding DataSnap's performance characteristics, with respect to delivering fully stateless RESTful services, is the intent not to continue to evolve DataSnap and truly improve its performance?
Well, sessions aren't necessarily the reason why DataSnap has some performance issues. We found some issues, and we continue to work on performance issues all the time. Some of them may be related to the remoting, underlying remoting technology. Some are related to how it's architected. But we intend to keep DataSnap under its current architecture, which is using these sessions, because this is how many of the current implementations take advantage of it and use it. Whereas EMS is going to be an alternative approach around a fully standard REST stateless approach.
Gary was saying in DataSnap, if I use lifecycle set to invocation, isn't that stateless?
Well, in theory, yes, but DataSnap has a architecture underneath it that continues to manage the state to deliver. If you're doing things like passing database information around, it does still manage some of that stuff through sessions.
Dante's asking, where can we download this sample? Watch the video and follow the steps.
Yeah, it's really just one line of code.
Yeah. There are samples with XE7.
There's actually a very nice sample called Notes, which shows you how to do similar types of things which I shared today, which is about exposing REST services, but it goes a step further, which shows you how to deal with things like user authentication. So definitely recommend checking out that sample for a more full-featured and complete example.
Enrique's asking, can EMS Server run on other platforms?
Today it runs on Windows and IIS. We have announced that we are working on a Linux backend server implementation for both DataSnap and EMS. And additionally, that means, of course, Apache will be one of those target web servers as well in the future.
There's a question, Wayne. What is performance like for EMS versus DataSnap when it comes to passing database data back and forth?
That's a good question. It depends on a couple of things, how the system is load balanced, and with EMS it's going to be easier to scale that way, again because you don't have to deal with session management between multiple entry points. DataSnap can do some things faster too because it has the benefit of sessions and caching, which it can take advantage of. So there's trade-offs. I'd say it depends on how you architect your application ultimately.
I suspect it's going to be the database server query speed and the network transmission speed.
Largely, and what's something to also keep in mind for mobile is that stateless is much friendlier on the battery. So compared to something that keeps a session open, you could end up using quite a bit more battery or resources from the mobile device to manage that client-side aspect of it.
Yep. Let's see if I understand this one. I have enterprise, and if I design EMS package to sell, I can package the entire product and the client only having to purchase the number of licenses. There's nothing else I have to be concerned with about deployment.
Basically, yes. That is the model. You design an EMS package. Somebody would have to, you would install it on the customer site, and they would have to have a license for the number of users that they want to access those services.
So there's no price for the EMS server.
Correct.
It's based on the user.
Correct.
Pavel's putting a comment. In the notes demo on the client, there's TEMS provider component on the client, which should be used, question mark, TEMS provider or TREST client, like in the demo?
That's a good question. The TEMS provider has additional built-in support. It was modeled after the backend as the service interface that we have. So it gives you additional features around things like user management, for example, whereas just the pure REST client is a much lower level control. To put it another way, the EMS provider or the provider backend as a service provider type controls utilize TREST client underneath to do all the heavy lifting for them, but they add additional support on top of that.
Is there a conversion, or how difficult it will be to convert DataSnap to EMS, where we have a lot of middleware code in the DataSnap Windows service? You can keep your DataSnap servers as well. Anything that's in those modules or packages that you build can call whatever it wants. It could call a SOAP server, a Corbus, or well, I don't know. We don't. Some other server. It could do a HTTP on its own. It could call a DataSnap server.
I think if you want to make a full conversion, though, it really kind of depends on what components you're using within DataSnap. And also if you're making assumptions about session information. So that's going to be the thing that you need to evaluate. But as David said, you don't need to do a wholesale conversion. You can do piecemeal, you can do some services on EMS, some on DataSnap. I mean, there's a question here or a comment that EMS seems ideal for corporate use. And that's largely who we designed it for, these enterprises that have to manage these concerns that we shared with you, these challenges to mobilize and to analyze and to work with the standard REST implementation. So, both have their place. I mean, another nice, interesting observation was that they're complementary technologies, not really competing. And I'd say, yeah, that's largely true. They can do a lot of the same things. It depends on how much you want to invest in building some of those services for yourself, or what your architecture requires in terms of stateless versus session-based approach.